So imagine you walk into a massive, like an infinite library.
Right.
You walk up to the front desk and ask the librarian for a manual on how to build a wooden birdhouse.
A pretty simple request, yeah.
Exactly. And the librarian instantly hands you a beautifully written, perfectly formatted book. But here's the catch. That librarian doesn't actually know what a bird is.
Or would, for that matter.
Right. They don't even know what a house is. All they have done is, well, they've memorized the statistical probability of those specific words appearing next to each other based on, scanning millions of other books.
It sounds bizarre when you put it like that.
It really does. But that illusion of understanding,
Yeah.
that is exactly how the generative AI tools you use every single day actually operate. I mean, they are brilliant at mimicking the shape of knowledge, but they don't truly understand a single word they're saying.
And that fundamental lack of comprehension, that's really the root cause of the most frustrating moments you have with AI.
Oh, absolutely.
It's the reason an AI can write a brilliant, structurally perfect sonnet in one breath and then just completely confidently hand you a fabricated legal citation in the next. It is relying entirely on patterns, not meaning.
Which is why, in today's deep dive, we are unpacking a research paper that might just, fix this permanently.
Yeah, this is a big one.
We are looking at a state-of-the-art research paper titled Gyan, an explainable neuro-symbolic language model. And this paper proposes a total paradigm shift.
It really does.
It claims to solve the biggest, most expensive headaches of modern AI. So the hallucinations, the massive computing costs, and that really frustrating black box reality where we have no idea how the machine actually arrived at its answer.
Yeah, this is a complete rethinking of machine intelligence from the ground up. Because, if you have ever stared at a screen completely baffled by a wrong answer from a chatbot and wondered what on earth it was thinking.
Well, been there.
Right. Traditional models physically cannot tell you. They just don't know. But the architecture introduced in this paper completely separates the brain, like the language processing engine, from the library, which is the actual knowledge data.
Okay, let's unpack this.
Yeah.
Because we are constantly hit with news about new models, right? We have GPT, Llama, DeepSeek, Claude, and these massive, new, large reasoning models.
Constantly. There's a new one every week.
Exactly. But despite their amazing test scores and the
Yeah.
billions of dollars poured into them, this paper argues they are all trapped in the exact same architectural dead end.
They were.
They don't understand what the paper calls compositional context, the way you or I do. But hold on, before we go further into how Gyan fixes this, what is that trap? What actually is distributional semantics?
Right.
Are we basically just talking about a really fancy version of the autocomplete on my phone?
That is essentially it, yeah. Just scaled up to an unimaginably massive degree. Current neural transformer-based large language models, or LLMs, are probabilistic models of word sequences.
Right.
They are built on a linguistic philosophy proposed by a linguist named Zelig Harris back in the 1950s. Harris argued that you can know the meaning of a word by the company it keeps.
A company it keeps.
Yeah, so if the word doctor frequently appears near the words hospital, medicine, and patient, the model learns that statistical association.
Oh.
It doesn't know what a doctor physically is, just that the word belongs in that specific neighborhood of text.
So during that massive pre-training phase where they feed the AI the entire internet, the data and the model are permanently fused together.
Exactly. They are learning the shape of the language and the facts of the world at the exact same time, in the exact same mathematical weights.
It is like a giant fruit smoothie. Like the AI model and the data are blended so completely that you can never separate the strawberry from the banana.
That's a great way to put it.
And if there is a rotten piece of fruit in there, say a piece of false information or a bad bias, it is just part of the smoothie now. You can't reach in and pull it out.
That is the perfect way to visualize the problem. And it brings us to how Gyan operates completely differently. Instead of Harris's statistical approach, Gyan leans on a different linguistic philosophy championed by J.R. Firth.
Okay, so who is Firth?
So Firth argued for something much closer to actual human cognition. When you read an article, you don't just predict the next word based on probability.
Right, that would be weird.
You actively expand the context in your mind using specific episodic details from your memory, combined with broader, abstract logic. Gyan doesn't use word frequencies at all.
Wait, not at all?
Not at all.
No.
It uses a deep linguistic pipeline. It relies on syntactic representation, semantic roles, and rhetorical structure.
Let me see if I can adapt our analogy here. If a traditional LLM is a blended smoothie, Gyan is like a master chef in a highly organized commercial kitchen.
Oh, I like that.
The chef, so the model itself, is completely separate from the pantry, which holds the ingredients, or the knowledge. The chef knows how to cook, but the ingredients are kept in carefully labeled jars. But wait, I have to push back here. If this model isn't pre-trained on billions of words to learn those statistical patterns, how does it even know how to read English out of the box?
What's fascinating here is the engineering behind it. Gyan is a non-transformer architecture. It can process any English document without any training whatsoever because it relies on deterministic, rule-based linguistics.
Rule-based?
Yeah. Instead of guessing the next word, it literally diagrams the sentence. It breaks down the syntax, identifying the nouns, the verbs, the prepositional phrases, and uses that strict structural logic to decompose the document into a mathematical graph of meaning.
So it's actively mapping the concepts rather than just playing the world's most expensive game of guess the next word.
Exactly.
That naturally leads to the next question then. If the chef is completely separate from the pantry, how exactly is it stocking that pantry with knowledge? How does it build that map?
It does this by creating something called a Gyan meaning representation, or GMR.
A GMR, okay.
No. Let's say you feed Gyan a dense 50-page report. It doesn't just swallow it whole, it dissects it step by step. First, it breaks the text into discourse units.
Discourse units.
You think of a discourse unit as a single, indivisible thought. If a sentence says, "The company profits rose and the CEO resigned," that is one sentence, but it contains two distinct discourse units.
Two separate events, two separate facts.
Exactly. Gyan separates them. Then it breaks those units down further into individual concepts and, most importantly, the relationships between those concepts. It builds an abstract pathway.
Interesting.
The paper gives a fantastic, simple example. If Gyan reads the word parrot in a text, it doesn't just store the letters P-A-R-O-T, it dynamically links it to a broader hierarchy.
Like a category.
Right. It maps a pathway showing that a parrot is a type of bird, and flock is the collective noun for birds. It maps the taxonomy of reality.
So instead of that massive multi-million-dollar pre-training phase, Gyan is acquiring knowledge in real time, mapping it and depositing it into what the paper calls knowledge stores.
Yes, exactly.
And reading the paper, these stores aren't just a messy junk drawer of facts. They are meticulously categorized into 4 distinct layers of trust.
The categorization is vital. Because Gyan relies on facts instead of probability, it needs to know how much to trust a piece of information. The first layer is factual knowledge.
Like dictionaries.
Yes, your undeniable ground, truth dictionaries, scientific taxonomies, encyclopedias. The second layer is expert studies. This would be empirical evidence, like peer-reviewed medical journals from databases like PubMed.
Which are highly credible, but slightly different from a pure dictionary definition.
Right. Then there's layer 3, which is expert opinions. This covers things like financial analyst reports or professional commentary. It's educated, but it's an opinion.
Makes sense.
And finally, layer 4 is speculations. This captures the wild west of information, so blog posts, social media, internet discourse.
Wow, okay. So by physically separating these into layers, Gyan knows the mathematical difference in weight between a peer-reviewed oncology paper and a random tweet about a supposed cancer cure. But let's dig into the mechanics of that, because this is where a lot of rule-based systems hit a wall. Here's where it gets really interesting.
Yeah.
If a sentence can technically apply to multiple different discourse units, how does Gyan decide where it belongs without just guessing based on word frequency? How does the math of this semantic weighting actually work?
It resolves those structural conflicts using semantic strength based on concrete linguistic rules. Let's look at pronouns, for example.
Okay.
If sentence A explicitly names the hospital administrator and sentence B simply uses the word she, Gyan doesn't guess who she is based on what words are nearby.
Right.
Its rule-based engine mathematically weights a direct reference higher than a co-reference. It anchors the pronoun to the strongest, most direct noun in the conceptual graph. And what this robust mapping allows Gyan to do is automatically expand its understanding by pulling from those knowledge stores to create a world model.
A world model,
Yeah.
meaning it is connecting dots that aren't explicitly stated on the page.
Exactly. It is mimicking human prior knowledge. Think about how you read a novel. If the author mentions that a character walked their golden retriever, the author doesn't need to stop the story to explain that a golden retriever is a dog, it has 4 legs, it barks, and it sheds hair.
No, of course not.
No.
You already have that world model in your head.
Right. Because Gyan maps everything hierarchically into its knowledge stores, it builds that same contextual world model dynamically. When it reads golden retriever, its internal map immediately lights up the pathway to dog, bringing all the associated traits into the context without needing to be told.
Which sounds absolutely brilliant in theory. I mean, having a pristine, perfectly organized mental map of the text makes perfect sense.
It does.
But having a good map doesn't mean you can actually win the race. We have seen decades of neat theoretical models that sound great in a research paper, but when you put them up against the brute computational force of a trillion-parameter generative AI, they just get crushed.
That's usually the story, yeah.
So looking at the hard data, what happened when they actually benchmarked it?
Well, the researchers knew they had to prove this against the industry standard. They tested Gyan against the exact same rigorous benchmarks used to rank models like GPT-4 and Claude. First, they looked at a dataset called MS-MARK-O.
Okay, what is that?
It's a massive benchmark for passage ranking, basically how well an AI can find the most relevant paragraph to answer a specific question out of millions of documents. And they ran this as a zero-shot test.
Wait, slow down for a second. A zero-shot test, meaning Gyan had never seen any of the test material beforehand.
Not a single piece of it. It had zero prior training on the test data. The only tool it had in its knowledge store was a basic dictionary called WordNet to understand synonyms. That is it.
Wow.
And despite having no training, Gyan hit the top 3 most relevant passages for 100% of the queries.
That is wild. It beat models that had likely ingested similar data during their massive training runs. But, passage ranking is one thing, reasoning is another. They also tested it on complex medicine, correct?
They did. They started with PubMed QA, a data set that requires the AI to give accurate yes or no answers based on reading highly technical medical abstracts.
All right.
Using just 32 medical dictionaries as its knowledge store, Gyan achieved state-of-the-art status, answering over 87% correctly. But the true gauntlet in the AI industry right now is a benchmark called MMLU medicine.
Right. And for context, if you aren't familiar with AI benchmarks, MMLU isn't just basic high school biology. It is a grueling, complex reasoning test that covers professional medicine. It is the benchmark that multi-billion-dollar labs use to prove their models are getting smarter.
And on MMLU medicine, Gyan achieved a state-of-the-art average score of 0.899. To put the significance of that into perspective, that score beats OpenAI's GPT-4o, it beats DeepSeek v3, and it beats Anthropic's Claude 3.5 Sonnet.
Okay, I have to play devil's advocate here.
Go for it.
Because anyone who follows the tech industry knows that companies are incredibly skilled at teaching to the test. If you know MLU is the benchmark everyone is watching, you can tweak your system to optimize for that specific multiple choice format. How do we know this rule-based chef isn't just gaming the system to get a high score?
The researchers anticipated that exact skepticism, which is why they subjected Gyan to aggressive perturbation tests.
Perturbation test.
A perturbation test is essentially where you try to break the AI by messing with the format. If a model is just memorizing patterns and you scramble the pattern, the model will fail. So they changed the order of the multiple choice options. They increased the number of options from the standard 4 up to 10. They even deliberately introduced typographical errors and noise into the dataset.
And what happened when they tried to break it?
Gyan's performance held entirely steady. The accuracy barely moved. This proves definitively that it isn't guessing patterns or relying on the vibes of the sentence. It is structurally diagramming the question, cross-referencing it against the facts in its knowledge store, and logically ruling the options in or out based on actual comprehension.
It is actually doing the math of the language. Acing medical exams is an incredible proof of concept, but if you are listening to this right now, you probably aren't taking medical board exams today. The real question is how this translates to messy, everyday tasks. Does this architecture survive outside the laboratory?
The paper includes some very compelling data on real-world applications. They tested Gyan on a 20-query internet search data set. They picked random, highly ambiguous search queries, the kind of messy things a normal person might type into a search bar, and pitted Gyan directly against Google search.
Oh, wow. Yeah, it's Google.
Yeah. They used strict academic metrics to measure the true relevance of the results, having human experts blindly grade them.
And the paper states that Gyan significantly outperformed Google in finding articles that were actually relevant to the user's intent, rather than just matching keywords. Its ability to filter out the noise and understand what the user actually wanted was vastly superior.
It was.
They also had great essays, right? They fed it open text responses from 57 students in higher education courses. Gyan evaluated the essays and achieved 100% acceptable results when compared to human professors in peer reviews.
But here's the detail that truly disrupts the entire narrative of the current AI industry. Think about what is required to run models like GPT-4 or DeepSeek.
Oh, sure.
You need massive, sprawling server farms. You need tens of thousands of specialized GPUs running so intensely hot that they require millions of gallons of water for specialized cooling. They're literally consuming the electrical power of a small city. The environmental impact and the financial cost are staggering.
It is the single biggest bottleneck in tech right now. It is why countries are fighting over semiconductor chips. So what kind of supercomputer does Gyan need to beat these models?
The paper states that Gyan requires negligible compute resources. It does not use a single GPU.
Wait, really? Not one?
Not a single one. Not for building its knowledge graph, and not for answering queries. It relies on a highly scalable standard CPU architecture that scales automatically based on the workload.
Let's pause and let that sink in. We are talking about an artificial intelligence that accurately grades college essays, beats Google at search relevance, and tops the charts on complex medical reasoning exams. But instead of needing a nuclear power plant to run a massive server farm, it runs efficiently without a single specialized GPU.
It's incredible.
It's like entering a massive gas-guzzling monster truck rally, winning first place using a bicycle. It fundamentally breaks our assumptions about how much computational fuel AI actually needs.
If we connect this to the bigger picture, the environmental implications alone are massive, offering a truly sustainable path forward for machine learning. But for enterprises, hospitals, law firms, financial institutions, the real game changer is security and trust. Because Gyan uses deterministic graphs, and because it relies on what are called extractive summaries, it literally cannot hallucinate.
Wait, underline that. It is physically impossible for it to hallucinate.
It is structurally impossible. An extractive summary means that when Gyan synthesizes an answer, it is pulling the exact subset of text directly from the source document. It does not paraphrase, it does not guess.
Okay.
When it gives you a fact, it hands you a traceable link back to the precise physical location in the document where it found it. For a business, this means you have an uncontaminated source of truth.
Because it isn't a smoothie.
Yeah.
If I am a massive corporation, I don't have to worry that the AI is going to accidentally leak my highly sensitive trade secrets to a competitor because they got blended together in the neural network. My chef is only cooking with my carefully guarded ingredients.
And there is zero cross-contamination of data.
Which naturally brings up the question of the future of the AI ecosystem. If Gyan offers zero hallucinations, negligible compute costs, and total data privacy, it sounds perfectly positioned to replace traditional large language models entirely.
Yeah, this sounds like an LLM killer. Why would anyone use a system that lies to them and costs millions to run when this exists?
Surprisingly, the researchers don't view it as a zero-sum game. They envision a highly collaborative future where neuro-symbolic models like Gyan and generative transformers actually work together. Gyan is built to be MCP compliant.
MCP?
Yeah, think of MCP as a universal translator that allows different AI models to seamlessly talk to each other and share tools.
Oh, so they can play nice. How does that collaboration actually work in practice?
Think of Gyan as the ultimate rigorous fact-checker for a creative LLM. You could use a transformer model to generate a fluent, engaging, creative response, and then route that output through Gyan to validate it against your factual knowledge store, instantly catching and preventing any hallucinations before the user ever sees them. Oh, I see.
Or working the other way around, Gyan can process a user's initial query, expand it using its highly accurate world model, and feed a contextually richer, flawlessly precise prompt into the LLM.
That is a fascinating combination. You get the conversational fluency and creativity of a generative model, tightly reined in by the strict, unyielding logic of a neuro-symbolic model.
Exactly.
But bringing up facts does bring up one major concern we have to address. If Gyan relies entirely on the documents it is fed, what happens when it reads a highly biased document? If it doesn't have its own internal bias, because it is just math and grammar, does it automatically fix the bias in the text?
This is a crucial nuance that the paper is very transparent about.
Yeah.
Gyan does not magically eliminate bias that is present in the source material.
Okay, good to know.
If you stock the pantry with biased ingredients, the chef is going to serve a biased meal. However, the critical difference lies in transparency. Because every single step of Gyan's reasoning is completely traceable through that meaning representation graph, you can immediately see exactly where the bias originated. So instead of a massive black box subtly giving you a biased answer and you having absolutely no idea why it thinks that way, Gyan hands you the answer and draws a bright red circle around the specific sentence in the specific document that caused it to arrive at that conclusion.
Yes, it makes the bias 100% visible and auditable. Furthermore, because of those 4 layers of knowledge source we talked about earlier, Gyan allows users to actively assign and adjust credibility levels.
Oh, nice.
If you realize a particular speculative blog is skewing your results, you can simply downweight its credibility in the system, and Gyan will instantly adjust its reasoning. You are in total control of the library.
We have covered a massive amount of ground today. We started by looking at the fundamental structural limitations of the statistical word guessers that currently dominate our world. We explored how a neuro-symbolic model like Gyan completely decouples the language engine from the knowledge library by literally diagramming the structure of the text.
And we saw how that deterministic map allows it to achieve state-of-the-art results in complex medicine and internet search, all while running without a single GPU, providing 100% explainable, hallucination-free results.
It truly is a testament to the power of rethinking foundational assumptions. This paper proves that a machine can continually approach a human analogous understanding simply by being given access to new, structured knowledge, rather than requiring the entire multi-million-dollar model to be retrained from scratch every time the world changes.
It is a totally different paradigm for how machines can learn.
It is. And as we move forward into this new era, we have to ask ourselves a fundamental question. In a world suffering from severe information overload, a crisis of truth, and very real energy constraints, is the future of artificial intelligence going to be based on mimicking the superficial patterns of human speech? Or is it going to be based on mimicking the actual structure of human thought?
That is the perfect, provocative question to leave things on. Think back to that infinite library and the librarian we talked about at the start of the deep dive. We have spent the last few years being incredibly impressed by how beautifully the librarian can mimic the sounds of the books they haven't read. But maybe, with models like this, it is finally time we gave them a map so they actually understand what the words mean. Thank you for joining us on this exploration, and remember to keep questioning the AI tools you interact with every single day. We will see you on the next deep dive.